everyone. My name is Henrik, and today I am going to introduce to you the best material on Earth in terms of potential applications or future applications, if you will, in my opinion. But first, I'd like to start off by telling you a story. When I was in the second year of university, I had a very good teacher. And basically because she didn't used to give the answers directly. She used to make us think before answering them. And then, one day, I came up to her at the end of the lecture, and I asked her, "Teacher, why is that the material's resistance and the density of this material seem to be positively correlated?" And then she said to me, "Oh, Henrik, why do you think that?" And then I said, "Oh, because I have been analyzing many materials, and polymers seem to be a little bit less resistant than metals, and as well as less with a lower density. And another example, teacher, is that aluminum has a lower density than steel, and it's also less resistant." And then she said to me, "Oh, Henrik, don't make these assumptions. You cannot do that. There's a very good saying that reads, it ain't what you don't know that gets you into trouble. It's what you know for sure that just ain't so." And so, Henrik, if you continue making those assumptions, that can prevent you from discovering new materials and finding out fascinating things regarding materials engineering. And then she said to me, "The best example, Henrik, that I can give to you is what I've been working on over the last years. It's called carbon nanotubes. This material is 5 times lighter than steel and at the same time 50 times more resistant mechanically." And then that's why I decided to do my presentation on carbon nanotubes, and the title of my presentation is "The Tunnel to the Future," because of their potential applications. So this presentation will argue that carbon nanotubes are a material that will revolutionize engineering in the near future, especially in the 21st century. And this will be done by first looking at the history of carbon nanotubes very briefly, and then the concept, what exactly are carbon nanotubes. The main properties will be discussed, their potential applications will be focused, and then their limitation, why exactly we cannot take advantage of carbon nanotubes, and then a conclusion at the end. First, before getting into the history, I just would like to ask you, do you know what nano stands for in the word carbon nanotubes? Does anybody have any ideas?
What's the question?
The nano, because
The size?
the material is called carbon nanotubes. Does anybody know what this stands for? Nano.
The size of the carbon atom?
Yeah, something like that. We can summarize by saying that this nano is 1 divided by 1 billion times. So we are talking about 1 meter divided by 1 billion. And that's the size we are discussing here today. Because the carbon nanotubes is a tube with a width on 1 nanometer approximately. So, as you can see here, with regards to history, carbon nanotubes are a very recent topic. This material was found out in 1991, so maybe the year you were born, so very recent. And their discovery, it was basically because you had graphite, and then you heated graphite up to 1,000 degrees, and then because of the atoms separated, and then it formed carbon nanotubes. However, carbon nanotubes were really scarce from the heating and not as good as they are today. And then in 1992, we've discovered the broad electrical properties of this material, because it ranges from a semiconductor, which is suitable for computer chips, for instance, to a superconductor, which I am going to explain later on. The great mechanical resistance was found out in 2000, that means 13 years ago, and as I have mentioned at the beginning, this material is 50 times more resistant than steel. And then, in 2001, the intrinsic superconductivity was found out that this material possesses them. Now, I want to describe what exactly are carbon nanotubes. First, until until 1985, only two forms of carbon were known by human beings. These were graphite, which consists of layers of atoms of carbon on top of one another. The other one, known by us, was diamond. There, the bonding of the atoms changed substantially. And then, as a result, we have totally different properties for the material. Consequently, we have different applications as well. And then, this is a variation, because this is similar to carbon nanotube in terms of how we acquire this material, because we heat up. Oh, and I forgot to mention, if you have only one layer of the graphite, because the graphite consists of graphene on top of one another, this is called graphene. And the fluorine consists of this graphene. You form a kind of a ball, a spherical form. And then, what I want to focus on today is the carbon nanotubes, which consist of a graphene, but you roll it up, you form a tube with that. First, I would like to mention a classification within this field, which consists of, if you have a layer of carbon, which is called graphene, and depending on how you roll it up, you can have different angles and different bonding system. And as a result, you have totally different properties. For example, here, these atoms that were here now are here in the carbon nanotube. Then you are a very good conductor of electricity. If you have like that, it's the conductivity decreases substantially. And then, even with a higher decrease of conductivity, is if you put these atoms like that. So the properties change according to how you proceed with the process of getting them. And here you can see the three types again, with a different view. Although it seems quite the same, their properties change dramatically. Another classification that we have for carbon nanotubes are what we call single-walled nanotubes and multi-walled nanotubes. These single-walled nanotubes consist of basically one layer of carbon, the graphene, if you roll it up. And on the other hand, if you have the multi-walled carbon nanotubes, you have several layers on top of one another, and you roll them all together up. And as a result, we have totally different properties and applications as a result as well. Here, I'd like to discuss with you the main properties of carbon nanotubes. First, the physical, which here I mentioned the density, which is roughly 1.4 grams per cubic centimeters, which is considerably lower than all metals, and by that I mean the structural metals such as steel or aluminum. And by that, we can get a lot of applications which require a low weight. And for example, if you have this material properly applied in airplanes, for example, you can have a lower weight and as a result, a lower consumption of fuel. And the mechanical properties, as I have mentioned before, it consists of basically 50 times more resistant than steel. And by this mechanical resistance, I mean if you have a material and you have a tensile strength, the tensile it will break will be 50 times higher. than steel, normal steel. And then the electrical properties, which particularly I am fascinated with, ranges from semiconductor to, in normal conditions, 1,000 times more conductor than copper, which is the metal widely used for transport of energy. And then you have the possibility of superconductivity as well, which I'm going to explain on the next slide. And then the thermal conductivity is quite high. It's on the same level as diamond, which under normal conditions is the material which possesses the highest thermal conductivity on Earth under normal conditions. And this material is really similar to diamond in terms of thermal conditions. Now, I want to bring a new concept for maybe some of you, which is called superconductivity. That's a phenomenon of zero electrical resistance. It's not 0.1, it's exactly 0. Here, I want to describe a non-superconductivity metal, such as copper or aluminum. And if you decrease the temperature, like that, the resistance gets lower as well. However, if you have a superconductor material, when you achieve a critical temperature, the resistance falls dramatically to 0. And then, if you have a temperature lower than that, you don't have any kind of resistance. And there are some superconductors that are known of, for example, mercury. However, the temperature to achieve is really low. For example, for mercury, it's minus 268 degrees Celsius. So it consists of high costs, and we are not talking about normal use, only very specific. And this material possesses that skill or this ability as well. And now I want to discuss the potential applications of this material. And about 3 decades ago, a concept was proposed which consisted of building an elevator from the Earth up into the space. That would mean 22,000 miles. I can write that for you to better have an idea of what I'm talking about. That's a really long distance elevator, and the costs are quite high. However, this material that I am discussing, carbon nanotubes, are the only material that would be able to withstand the pressure and the extreme conditions that this elevator would pose to because it's really, you have to have a lot of material. And for example, you could ask, oh, but why can't we build that with steel? We just make it larger. Because it's so high that it doesn't stand its own weight. And this material are the only material known. And if we have that in the 21st century, which is making more, this application would propose, for example, a new industry for tourism. For example, instead of going to Europe, I am going to space, for example. And another application would be, another result would be the waste disposal of nuclear energy, if you will. That's one application. Now, I want to discuss 5 other applications, which consist of faster computer chips, better solar cells, cancer treatment, flexible displays, and last but not least, body armor. First, faster computer chips. Because of the semiconductor properties of carbon nanotubes, you can have many more transistors in a chip than a normal material, because the length, as I have mentioned, is 1 nanometer. And by that, you can have many more transistors, and as a result, a much faster chip. Another is better solar cells for solar energy. This is due to 2 factors. First, this material, as I have mentioned, it has a really high thermal conductivity, which would make it feasible for the conductivity of the heat. And another thing is that it absorbs the light really, really well, and then it increases the efficiency. Another application, potential application, is cancer treatment. Because it is so small, you can get into a cell, and if you combine that with, for example, a protein, you can get only to the bad cells, not harming the good ones, and then it would make cancer treatment viable. Another one is flexible displays. Although we already have flexible displays, which are displays that you can do like that and it doesn't break, the ones we have today are not that good because you cannot blend that much, and the resistance of the material inside that is not as good as carbon nanotubes. And carbon nanotubes are also very flexible, which would make that feasible and good. Another one is body armor. And because of the extreme mechanical properties of this material, you could have a t-shirt, for example, that's bulletproof and it doesn't have a high weight. And the current material used for body armor is clever, but carbon nanotubes surpass the properties of clever by far. However, we have some limitations of this material, which consist basically of processing, the length, and toxicological issues. First, the cost of processing this material is quite high, and it's not viable yet for normal use. The length, as I have said, if you build an elevator up to the space, it would require 22,000 miles. However, the length that we have of carbon nanotubes nowadays are basically 3 to 4 centimeters. And if you build such a very big thing, you would have the carbon nanotubes like that, for example, and that decreases the mechanical resistance. It would be better if you have like that. And the length, it's increasing. It has increased a lot over the last years that we can process. And last but not least, toxicological issues. Some research have shown that the body or the cells do not accept carbon nanotubes that easily, and which would make it not viable, for example, for cancer treatment. And but work have been conducted on this topic, and over time it's believed that we will be able to manage that. Now I want to conclude my presentation. Here, as I have mentioned at the beginning, this material has impressive properties. For example, it ranges from mechanical to electrical, thermal, and even others. For example, even others. Carbon nanotubes are a material that would make it possible to apply in a lot of fields. And for example, as I have mentioned, medical fields, structural, electrical, and even thermal fields. And I think maybe the most important thing, time is still required for us to take advantage of this material, but it believes that in the 21st century we will achieve many more things. Now I'd like to thank you, and does anybody have any questions?
You concentrate a lot about the potential uses of nanotubes, but I think that's already been used in some areas.
Yes.
Do you know which areas?
Yes. In fact, I would ask you a question after that regarding what you were asking me. For example, you can use carbon nanotubes in a normal polymer, but not 100% of carbon nanotubes. You could use, for example, 1% or even 0.1%. And that would change the properties dramatically. Only use 1% of the fibers. That's what's called composites. And we would have, or even in metals, you can put a little bit only, not entirely. entirely. Any questions?
Are there larger or industrial production of carbon nanotubes?
Not really. It's only produced in laboratory, and we don't have industrial production of this material because the costs are too high.
Do you know which countries are producing?
Yeah, basically the most developed countries have they produce more than others, and the 3 countries that produce the most are Japan, Germany, and the US.
Nice.
So it's just experimental. They don't use
We
it
have
yet.
some applications, like I have said to Victor, for example, putting only 1% of carbon nanotubes, or even less, much less, in a metal or polymer to have better properties. You can use that in concrete as well, because then the failure of concrete would become less probable. You can have that.
Do you know how much time it will take to go to space with the elevator?
It's expected maybe 100 years, but it's...
No, I mean, what time it will take to
I
go?
don't know about that, but I can research on that.
Do you think that you can use these nanotubes in cars?
Yes, we can use that in cars, and with that we would reduce the fuel consumption, for example. Maybe not use it entirely in a part, but combining it with other materials. Does anybody have any more questions?
What question would you ask us?
So here I have 2 questions that I brought. First, do carbon nanotubes have a role to play in environmental protection?
I don't know.
I think yes. Because
Yes.
if you conduct energy in a more easy way, you can spend less energy with the waste.
And the biggest problem for renewable energy is the efficiency. So
Yes.
that could increase the efficiency.
Yes, and
But I think there are some problems related with the cooler system of these nanotubes.
yeah, we could say, for example, if this has been studied like to be applied in airplanes, and that would reduce the fuel consumption dramatically, and as a result, less carbon emissions, less greenhouse emissions, and other solar cells more efficient, that would change as well. So, yeah, any comments on that?
Do you know how much it would
Cost.
decrease the weight of the airplane?
It depends on how much you use, but it can change dramatically.
Yeah.
Do you have the density of this material?
Yes.
Do you have an idea about the metal density?
Yes. For example, as I have mentioned, this material is 5 times less with a lower density than steel. Steel is 7.8, aluminum around 3.5, and copper around 8.
So do you think if we use nanotubes in like cars, it would be like electrical cars? They would make them more viable because they consume less energy, so they could like go on the road for more time.
You were talking about the superconductivity?
No, because if you use it, the weight would be less, so you use less fuel.
We can use actually in all kinds of car, because we only in parts, for example, very teeny parts inside the car, and by that we would reduce the weight, and as a result, the consumption of fuel, any kind of fuel, it will be reduced because it depends on the weight.
And about the superconductivity, it would help too.
Actually, not entirely right. Not really, because the superconductivity requires a very extreme low temperature, with minus 200 degrees, for example, and that would make it not viable, only for very special research and not
Places,
for normal
yeah.
use.
Okay.
Do you use liquid nitrogen to coat this?
No, not really.
Do you know the
Maybe. I'm not sure about the temperature.
Do you know the critical temperature?
Of this material, I don't know, but I know that the mercury is around minus 268 degrees Celsius. By that, I mean 4.1 Kelvin, exactly. And however, research have been conducted on that, and we have materials now that can, with a critical temperature of maybe minus 60 degrees, and that's already feasible for laboratory or even for industry, depending on the field.
Very good.
Another question I brought.
Yeah.
How could carbon nanotubes be used in an inexpensive way, not with high costs, and making it viable for normal people?
By how to produce it or how to?
How to use that? How, for example, a part that's made up of this material. Do you have any ideas? As I have mentioned, you can combine it with other materials, for example, metals, polymers, or even ceramics. And with a very low quantity of this material, we can use that, take advantage of that, and as a result, change the properties dramatically.